Right, for part A, in order to show the angle BAC is 58.4, we are going to have to make use of the three lengths given. So with three lengths given and wanting to find the angle, we're going to be using cosine rule. So since BAC is the angle we want to find, we will start off with the opposite length, which is BC. There's a value of 6. So using our cosine rule, 6 square, 3 square plus 7 square minus 2 times of 3 times 7 cosine BAC. So now we need to manipulate and make cosine BAC the subject. Then we take the inverse to find our angle BAC. So round it off to 1 dp, 58.4 degrees. So this is shown. Now to calculate the surface area, we will need the sum of the two cross-sectional areas plus the sum of the lateral faces. So there are two cross-sectional areas, 2 times of either you use half times base times height, which requires you to find the height, or use the area for a triangle as half AB sine C, which since we've already found the angle BAC, we can use that. So half times the side, 3, times 7, times sine, instead of using 58.4, we use more decimal places. So this is the two cross-sectional areas, and we need to add the area of the lateral faces. So we do so by identifying the perimeter of the cross-sectional area. So that will be 3 plus 6 plus 7, and we're going to multiply it by 10. So that gives us the answer of 178 square centimeters to 3SF. Next part for C, to calculate the vertical distance of C above AB, identifying your diagram for easy reference. So this is the distance that they want. There are a few ways we can go about doing it. One of which is to use the angle that we found earlier on, 58.411. And since we have a right angle triangle, we need the opposite side given the hypotenuse. So using sine of the angle 58.4118, that will give us the height over 3. So the height will be 3 sine 58.4118 to give us 2.5555. So round it off, 2.56. Next, part D. To calculate the angle of elevation of E from A. So we need to identify where that is again. E from A. We need to drop a perpendicular line down from E to the base. So the same 90 degrees. We join the base. And we complete the right angle triangle. So this is the right angle triangle, and the angle of elevation is shown here. So let us call this point F, since it's not used. So when we isolate this triangle, we will see A, F, E. And this is our angle of elevation that we need. So there are a few things we need. We need two lengths in order to find the angle of elevation. So the first length that we have is actually EF, because that is the same perpendicular height as the answer in part C. So the height found that it was 2.555 with another 5 cm. We need a length. Is it easier to find AE or AF? So looking at the diagram, AE is easier because we already have the length of BD, which is the same as the length of this length at the bottom. Then we also have the 3 over here. So let me draw this face over here. So that is AC. It is actually a rectangle, E, with an unknown point over here that was not listed. So A to E, we want this distance. Here we have 10, and this is 3. So AE is given by square root of 10 square plus 3 square. So with these two sides, opposite and the hypotenuse, we can take inverse of the trigo ratio to find the angle of elevation. So the trigo ratio we're going to be using over here will be sine. So sine theta, let's call this theta, will be 2.5555 over root 10 square plus 3 square. So after you do a calculation, we get 14.168, rounded off to 1 dp, so 14.2 degrees.